Hello everyone, Coach Graber here. I want to go over the parallelogram properties that we worked on before spring break, just for review and to prepare for a mastery that we'll have this week. So this is the decimals activity we did with exploring these properties. I went to the third page where we start looking at the properties of the parallelograms. So on this screen here, we notice that the opposite angles are equal. So if this angle is 132, this one's also 132, 48 and 48. And that's true regardless of what the sides of those angles are. So in this case here, we changed the angles, but they're still the same across and still the same across this way. There's one other important fact here you may not have noticed when you're working through this. If you look at this angle and this angle, which are adjacent angles, if we add those two angles together, so 66 plus 114, then we have a value of 180 degrees. That's also true for every parallelogram. So the adjacent angles have to equal 180. The opposite angles that are across from each other will equal the same amount. So 114, 114. These two are supplementary. They equal 180. All right, so that's for parallelograms. Go ahead and jump to the next screen. So on this screen here, these three angles all equal 180. Now the purpose to that, or the reason why we know that, is because we have a triangle here, and all the angles in a triangle equal 180 degrees. Also, these angles are still the same as the angles down here in this triangle. So if this angle here is 55 degrees, and that means that this angle down here that's across from it, that's an alternate interior angle, if you remember that term, will be 55 degrees. If this is 34, then this angle down here is 34 degrees. This one's 91. This vertical angle would also be equal to 91. And since this angle is 56, this angle here would be 56 degrees. Okay, now looking at side lengths. Well, this one you're probably already familiar with. Opposite sides are the same length for a parallelogram. So 5.47 is the same as 5.47. 6.37 and 6.37 are the same. Doesn't matter how it changes, those facts are still true. These are the same, and these are the same. Now, for this one, you're looking at the diagonals. So this line across that's made of both the blue and the purple is one diagonal, and this is the other diagonal. Now, these diagonals are not the same length. This one is obviously shorter than this one. But what you will notice is that these two halves of the diagonals are the same. So this length is the same as this length here. The way we say that in geometric terms is these diagonals bisect each other, they cut each other in half. So this line and this line, when they intersect here, they cut each other in half. But these two lengths are the same, and these two lengths are the same. Okay, now we have a rectangle. So looking at the rectangle. Now, a rectangle is a type of parallelogram. So everything that's true for a parallelogram is also true for a rectangle. The opposite sides are the same. These two sides are the same. The opposite angles are the same. And the adjacent angles equal 180. What's different for this one is that all the angles are 90 degrees. Now looking at the diagonals for a rectangle is where things get different. So let's see if this next screen shows us. Here we go. So for the diagonals of a rectangle, what do you see? You look at all these measurements here, they're all the same. So for a rectangle, the diagonals are equal in length. That's not true for parallelograms, just rectangles. So this length here is exactly the same as this length here. And if they cut each other in half, then all four of these parts will be the same. Now we have a rhombus. Rhombus is a parallelogram where all the sides are the same. So you see here that these sides are all 5.61. Now here's another thing that's special for the rhombus. The diagonals, when they cross each other, are always perpendicular, meaning these angles are 90 degrees. So this angle is 90, this angle is 90, these two angles are also 90. That's true for any rhombus. So if the sides are all equal for your parallelogram, that makes it a rhombus. And if it's a rhombus, all these angles created by the diagonals are 90 degrees. They're all perpendicular. You also notice that these angles are the same, these angles are the same, these two are the same, and these two up here would be the same. So if this is 61, this is 61, this is 61 down here, and this is 61 here. And all these angles here are 90, as we just mentioned, for a rhombus. And these angles will both be 29. So we have four triangles that are all the same. They're all right triangles that are congruent to each other. So for the rhombus, this is not a rectangle. So these measurements are the same, but they are different from the 5.32 and the 5.32. What's important for the diagonals of a rhombus is, again, they're perpendicular. This angle is 90. Finally, for the square. So a square happens to be both a rectangle and a rhombus, meaning that all the sides are the same and all your angles are 90 degrees. What that means for a square is that everything that's true for a rhombus or a rectangle is true for a square. So you'll see that the angles created by the diagonals are all 90 degrees. Side lengths are all the same. These angles are all 90. Everything's the same pretty much. Here, the diagonals are the same length because this is a rectangle. These angles all match. In this case here, the diagonals are all 4.31, or the diagonal halves, that is. The whole diagonal is actually all the way from here to here, which would be 8.62. Okay, so looking at your family tree, you would say the square is made up of both the rectangle and the rhombus. So you put your tree something like this. The rectangle could be over here, rhombus could be over here. This could be switched. But what's important is that both of these are parallelograms, but they're different from each other. And the square is both a rhombus and a rectangle. All right, guys, if you have any questions, send me an email or message me on GroupMe. We're going to be doing an Alex activity over this, where you're using these properties, and we will have a mastery soon. So keep in touch. Let me know as questions come up. And remember, I'm always here to help. Have a great day.